Hello dear students, in this video I'll continue with the fifth unit, which is Inferential Statistics. In this video I'll continue with hypothesis testing. Here we will learn about the t-test for two independent samples. Now first we will see what is this t-test for two independent groups or two independent samples. This test, it compares the two groups. These two groups can be in the form of experimental group and the control group. It helps us to see whether a statistically significant difference exists between the means of these two groups. So this two sample t-test, it compares the means of two groups. Now what is this experimental group and what is this control group? Now say for example, if a researcher wants to study the effectiveness of yoga on employees of a company, what the researcher will do? The researcher will divide the entire employees in the company into two groups. Now it need not be equal groups, it can be of different sizes. So one group will be called the experimental group and the other group will be called the control group. On this experimental group, the researcher will make the employees perform various yoga exercises and he or she will test the effectiveness of yoga on this group by comparing those members in the control group where no experiment is done. That is, in this control group, they will not be performing any yoga exercises. So the group which performs various yoga exercises will be the experimental group, and the group which do not perform any exercise or which do not receive any treatment will be the control group. Now the effectiveness of this yoga, it will be studied by comparing the experimental group and the control group. So this is the use of t-test for two independent groups. In one sample t-test, we used to have the hypothesis as the null hypothesis is given by mu equal to some value mu naught and the alternate hypothesis as mu not equal to mu naught. As far as this t-test for two independent groups are concerned, we have two populations, population 1 and population 2. A small sample is drawn from this population 1. It is called sample 1, and a small sample is drawn from this population 2 and it is given by sample 2. Now the various population parameters for population 1 consists of population mean for population 1 given by mu 1, then population variance for population 1 given by sigma 1 square, and population standard deviation given by sigma. Similarly, the population parameters for the second population, it is given by mu 2 sigma 2 square, which is the variance, and sigma 2 is the population standard deviation. Now as far as the sample is concerned, we have the sample statistic. The sample mean for the first sample is given by x1 bar and the sample standard deviation for the first sample is given by S1. Similarly, for sample 2, the sample mean for the second sample is given by x2 bar and the sample standard deviation for the second sample is given by S2. In this t-test for two independent groups, the hypothesis takes the form there is no significant difference between the mean of these two groups. So the meaning is that the null hypothesis will be given by H naught is mu equal to mu 2 and the alternate hypothesis H1 will be given by mu 1 not equal to mu 2. So the null hypothesis is a statement of no difference. It states that there is no difference between the means of these two groups, and the alternate hypothesis states that there is significant difference that exists between the means of these two groups. And now when we take this t-test, it is a small sample test. So for two independent groups, if we consider this t-test, we have two different cases. The first case, we assume that the variances are equal. So the sample from the population from which the samples are drawn, those population will have equal variance. So the first case, we assume sigma 1 square equal to sigma 2 square. That is the first case. In the second case, we assume that the variances are unequal. So, here we assume that sigma 1 square not equal to sigma 2 square. In one sample t test, we used to find the test statistic t. Similarly, in each of these cases also, we have a formula for finding the test statistic t. So here we have two different cases when the variances are assumed to be equal and when the variances are assumed to be unequal. But we do not know what is sigma 1 square and what is sigma 2 square. If we know the values for sigma 1 square and sigma 2 square, we will be able to understand whether it is equal or not equal. So how we can identify whether the given data is of the form where variances are assumed to be equal or where variances are assumed to be unequal. We have only the values for the sample statistic. What we can do is, we can compare the sample standard deviation of these two samples to a particular value. Now, if we have the sample standard deviation of first sample more than the sample standard deviation of second sample, in this case, we have to find S1 divided by S2. If this value is more than 2, then it is for variances are assumed to be unequal. On the other hand, if the sample standard deviation for the second sample is more than the sample standard deviation of the first sample, if S2 is more than S1, then we have to see this ratio S2 upon S1. If this is more than 2, then again we have to consider this case when the variances are assumed to be unequal. If this ratio is less than 2, then we can proceed with case 1 itself when variances are assumed to be equal. Again, if S2 is greater than S1 and if this ratio is less than 2, again we can proceed with case 1. So while doing problems, we will understand this condition. Now this is a simple rule of thumb which can be used to find which type of test statistic t we have to use according to the assumptions that we are making. Now we will see the test statistic t when the variances are assumed to be equal. So here when two independent samples are assumed to be drawn from populations with identical population variances, that is, we assume that sigma 1 square equal to sigma 2 square, then the test statistic t, it is computed as t equal to the sample mean of the first sample x1 bar minus sample mean of the second sample x2 bar upon SP into root of 1 by n1 plus 1 by n2, where n1 is the sample size of the first sample and n2 is the sample size of the second sample. Now what is this SP? This SP, it is called the pooled variance and it is calculated as SP equal to root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So this is the formula for SP, where S1 is the standard deviation of the first sample, S2 is the standard deviation of the second sample, and SP is the pooled standard deviation, or it is the combined estimate of the overall standard deviation. And N1 and N2 are the sample sizes of the first and second sample respectively. So when the variances are assumed to be equal, we use this formula for the test statistic t. It is given by x1 bar minus x2 bar upon SP into root of 1 by n1 plus 1 by n2. And now we will see the steps in hypothesis testing. procedure for testing the hypothesis by using the t-test for two independent samples. Here when the variances are assumed to be equal. So the first step is we have to state the hypothesis. So we have to state the null hypothesis H naught. There is no significant difference between the means of two population, and the alternate hypothesis H1. There is difference between the means of two groups. So H naught is mu1 equal to mu2 and H1 is mu1 not equal to mu2. Step 2 is we have to define the test statistic T. It is given by x1 bar minus x2 bar upon SP into root of 1 by n1 plus 1 by n2. Now we have to calculate the value for this T using this formula, find T and the critical value of T from the table with n1 plus n2 minus 2 degrees of freedom at alpha level of significance. So when we have a single sample, we used to have degrees of freedom as n minus 1. Here we have two samples. So the degrees of freedom will be n1 minus 1 plus n2 minus 1, which is n1 plus n2 minus 2. So we have n1 plus n2 minus 2 degrees of freedom for this t-test for two independent samples when the variances are assumed to be equal. Now we have to compare this critical value of T with the calculated value of T. Accordingly, we have to make the decision to accept or reject H naught. And finally, we have to summarize the results based on what is given in the question. So these are the steps for hypothesis testing using t-test for two independent samples when the population variances are assumed to be equal. Now we'll see an example. Now this question I have taken from exercise 21.2 applied mathematics by D Sharma. It says samples of two types of electric bulbs were tested for length of life and the following data were obtained. So samples of two types of electric bulbs were tested for the length of life. So this is the data which were obtained. We have two types of electric bulbs. The number of bulbs in the sample is the first type had 8 bulbs, second type had 7 bulbs. Then the mean life of bulbs in hours in the first type is 1134 and in the second type it is 1024. Then the standard deviation in hours for the first type of bulbs is 35, second type is 40. Now we have to test whether the difference in the sample means whether it is significant or not. So here it is given. We have to use a two-tailed test. So here T 0.05 for 13 degrees of freedom, it is 2.16. Now this is nothing but it is the area in two tails only. So it is nothing but it is the value for T 0.025 for 13 degrees of freedom. It is 2.16. And now let us do this question. Now first what we have to do? We have to see whether we can assume the population variances are equal or unequal. We have to see whether we can use the first case or the second case. So for that, the rule of thumb that we can use is, here we can see that S2 is greater than S1. This is the sample standard deviation for the first group and this is the sample standard deviation for the second group. Here S2 is more than S1. So we have to see S2 divided by S1. It is 40 by 35. It is not more than 2. It is less than 2. So we can assume the first case. That is, we can use t-test for two independent groups when the population variances are assumed to be equal. So here we have N1 is 8, N2 is 7, X1 bar is 1134, X2 bar is 1024, S1 is 35 and S2 is 40. So all these values are given directly in the question. We verified whether we have to use the test statistic for the first case or the second case. Since this S2 by S1 is less than 2, we can assume that the population variances are equal. That is, these two groups were drawn from population having equal variance. Now let us write the hypothesis. Define null hypothesis H0 and alternate hypothesis H1 as follows. So the H0 is, we assume there is no significant difference between the means of two groups. So H0 is mu1 equal to mu2. And alternate hypothesis H1 is mu1 not equal to mu2. Now after seeing this hypothesis, we can see that it is a two-tailed test. Thus a two-tailed test is applied under hypothesis H0. We have T is equal to x1 bar minus x2 bar upon SP into root of 1 by n1 plus 1 by n2. So it is x1 bar minus x2 bar upon SP. This 1 by n1 plus 1 by n2, if we take LCM and simplify, it is n1 plus n2 upon n1 n2. Here this is in the denominator. So if we take it to the numerator, we get it as into root of n1 n2 by n1 plus n2. So let us first find what is the pooled variance SP, and then let us substitute all these values. So SP equal to root of n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. So it is root of n1 is 8, s1 square is 35 square plus n2 is 7, s2 square is 40 square upon n1 plus n2 minus 2. Let me continue here. So SP is root of 9800. This, when we simplify, we get 9800 plus 11200 upon 8 plus 7 15 minus 2 13. So it is root of 21,000 divided by 13. This, when we simplify, we get it as 1615.38. So here we have to find the square root of this number. 1615.38. Let us find square root up to 2 decimal places. So I am adding 2 more zeros. So we have to take the integral part in pairs and the decimal part in pairs. So if we see the first pair of digits, it is 16. 4 into 4 16. 0, bring the next pair of digits, it is 15. Add the quotient plus 4. So the next divisor will be 8. Since here we have 15, we cannot have even 1. So let us have 0, 0. There is a point here. So here we will have 15 again. Bring the next pair of digits, 38. So here, since we have had the next quotient as 0, again we have to add 0 to this. So here we will have 80. We cannot have 802 into 2. It will be more than 1600, but here we have 1538. So let us have 1. So here we have 801. If we subtract, we get 7 3, 7. Bring the next pair of digits. So the last quotient that we had is 1. Add this 1. We get 802. And here it is very close to 8020. So here let us have 9. 8029 into 9. It is so square root of 1615.38. It is equal to 40.19. So SP equal to 40.19. All these can be done in the rough. Now let us find T. T is x1 bar is 1134 minus x2 bar is 1024 upon SP is 40.19 into root of n1 is 8, n2 is 7. So 7 into 8, 56 upon 7 plus 8, 15. So this, it is 110 upon 40.19 into root of 3.73. So here 110 by 40.19, it is 2.73 into root of 3.73. Let us try to find the square root here. All these can be done in the rough. So 3.73, we have to take the integral part and the decimal part in pairs. To find the square root up to 2 decimal places, let us add 2 more zeros. So here we have 3. The perfect square is 1 square. So 1 into 1 is 1. Then we have 2. Now we have to add the quotient which we just now got. 1 plus 1 is 2. Here bring the next pair of digits. It is 73. Here there is a decimal point. So let us keep a decimal point here. Now 29 into 9. It is 261. This is 6. Okay, and then here it is 12. Now let us bring the next pair of digits. It is 0, 0. 29 plus 9. It is 38. Let us try 3. 383 into 3. It is 1149. So square root of 3.73 is 1.93 into 1.93. Now this, when we multiply, we get it as 5.28. So we get T as 5.28. The critical value of T is 2.16, but we get T as 5.28, which is more than this 2.16. So we have to reject H naught. So here if we see the region of rejection, it is a two-tailed test, so it is on both sides. Here we have negative 2.16 and here we have positive 2.16. This 5.28, it lies somewhere here, which is the region of rejection. Since T equal to 5.28 does not lie in the interval, minus T 0.025 to T 0.025 for n1 plus n2 minus 1, that is 8 plus 7, n1 plus n2 minus 2, that is 8 plus 7 minus 2 equal to 13 degrees of freedom. We reject H naught. Let us write the value also, that is negative 2.16 to 2.16. We reject H naught. It is not necessary to draw this graph. It is only for a better understanding I have drawn this graph. So we reject H naught. As a result, we conclude that there is significant difference between the sample means of the two types of electric bulbs. Hence, we conclude that there is significant difference between the means of two types of electric bulbs. So this is how we go about for the two sample t-test when the population variances are assumed to be equal. I hope this video was useful for you. In my next video, we'll see how we can use the t-test for two sample when the population variances are assumed to be unequal. If you have not subscribed to my channel, please subscribe. Thank you for watching.